Welcome to Shifting Grades. We are still continuing with the mathematics topic, longitudes and latitudes. Yesterday we began the topic, and one of the major things which we stated in the previous lesson, and I would like to emphasize, is how to locate a place on the Earth's surface. And we said that for you to identify the position of a given place, then we observe the intersection of its latitude and longitude in that order. Therefore, we place the coordinates of a given place as a coordinates of the latitude and the longitude in that order. And this is how we plot a place on the Earth's surface. If, for example, you are told that Nairobi is 1 degree south and that 7 degrees east, then for you to identify where Nairobi is on the Earth's surface, you draw the globe just like this. Then you come up with 0 degrees prime meridian and 0 degrees equator. Then now the coordinates of Nairobi are saying that Nairobi is 1 degree south, so a latitude which is 1 degree south, just above the equator, 1 degree south. Sorry, south should be below. This is the north part. 1 degree south, slightly below 0 degrees. So 1 degree south and that 7 degrees east. So east is the right hand. Therefore that 7 east. That's 7 degrees east. Therefore now, where that is 7 degrees east and 1 degree south are intersecting, this intersection will give us the town we want. Like that. Therefore, that's how we locate a place on the Earth's surface. Today's subtopic is longitude and latitude difference. Longitude and latitude difference of places on the Earth's surface. Therefore, because in the next one we will be doing the distance along small circles and great circles, it is good to first of all know longitude and latitude difference. Therefore, it's good to first of all master this, that for places on the same longitude, we find, if they are on the same longitude, we find the latitude difference. If they are on the same longitude, we find the latitude difference. Now, this is what we are saying when we talk of latitude difference. When we have two places, consider places P and Q on the same longitude, but on latitudes, these degrees, north and alpha degrees on the south, like that. Therefore, I try to sketch the two places. This is 0 degrees prime meridian. This is 0 degrees the equator. Now, if our places P and Q are on the same longitude, like for example this one, they are on the same longitude like that. When we talk of different latitudes, like Q or this theta to represent an angle, degrees north, theta degrees north, like that, and the other one is alpha south, a different angle, alpha degrees on the south. Then now, whatever we are calling the latitude difference is the difference between the latitude on which, so this is P, because you said respectively, the difference between the latitude on which P is lying and the latitude on which town Q is lying. Therefore, because we can see they are on the opposite side of the equator. If this is the equator, we have the two places on the same longitude, but P is on latitude theta degrees and Q latitude alpha degrees. Then the difference in latitude of P and Q is the sum of the two angles, because we have theta degrees upwards and alpha degrees downwards. Therefore, we can say the latitude difference is equals to the angles added when the angles have been added, like that. Therefore, if P is, for example, 40 degrees north and Q is 38 degrees on the south, then we would have said that the difference in latitude between these two places is 40 in the north and 38 in the south hemisphere. And therefore, in real sense, if we add this as an example now with 40 and 38, the difference would have been the sum, 40 plus 38. This gives us a 78 degrees. It is the difference, just degrees, not east or west or north and south. Again, consider two places, A and B this time around, on the same longitude again, but on latitudes alpha degrees north and theta degrees again north, like that. This is what we are saying. If you find now, again, we are having 0 degrees equator and 0 degrees the prime meridian, then the two places are on the same longitude. Let's say that is the longitude where they are. Then they are both on the north part, but A is alpha degrees north. So A is alpha degrees north. This is alpha degrees north. And Q plus B, is theta degrees north. It is also northward, but at a lower angle. Therefore, you find now, this is A, this is B. Now, they are on different latitudes. A at alpha degrees north, B at theta degrees north. Therefore, they are on the same longitude, but on the same hemisphere, or on the same side of the equator. And therefore, in this case, you find the latitude difference now will be the difference between the two. We are not now adding, because when we take For example, this is at 40 degrees north side, and this one is at 75 degrees also north. So you find from A to B, then the difference in latitude is when you subtract the latitudes of the two places, and therefore we say now latitude difference will be the difference now, alpha minus theta degrees. And if we take this as an example, we'll have 75 minus 40. This will be 35 degrees. Therefore, because they are on the same side of the equator, we differentiate, or we take the difference. When they are on opposite sides, this side and this side, as we had stated, we add, we sum up for us to get the difference in degrees. So that's about latitude difference. We should also note that when places, note that when places are on the same latitude now, we find the longitude difference. The longitude difference, for example, take, or we consider P and Q, or Q and P, on the same latitude but different longitudes. If we have two places, this is 0 equator, 0 prime meridian. So if we have two places on the same latitude, let's say they are on latitude, this one, they are on latitude 40 degrees north. They are both lying there. Then we have them on different longitudes. Like Q can be here. Q can be here, theta degrees on the west. And P can be on the other side of prime meridian, alpha degrees on the east. So you find now P is here now. For us to get the difference between Q and P, because the prime meridian is in between them, then the difference in the angle or the longitude, the longitude difference, we say it is the angle where Q is plus the longitude where P is. And therefore, for us to get longitude difference, then it will be the longitude where Q is, and that is theta, and we add the longitude where P is, that's alpha. Like that. If they were on the same side, for example, if you find the prime meridian is here, but two places on the same side, like Q, and we say this one is R, we can say they are on the same latitude, but different longitudes. And therefore here, we'll come and say that now, the longitude difference. The longitude difference will be, if this is at a small angle A degrees, then we'll say that it is the angle where Q is, and it is theta degrees, and then we subtract the angle where A is, where R is, that's A degrees. Therefore, angles for places on the same side, we subtract, but if places are on the opposite sides, whether opposite side of the equator or opposite side of the prime meridian, then we subtract. Let me give an example. you are told find the difference in longitude between A and B. Find the difference in longitude between A and B. Then they are plotted in a globe like this with 0 and 0 prime meridian. Then we are told A is like that, 60 east. Then A is also at 80 north. A is at 80 north, 80 degrees north. So this is where we have A. Then B is 80 degrees east. So it's beyond, B is beyond A, 80 degrees east. And B is 30 degrees north. 30 degrees north. 30 degrees north. So B is here. So we are told B is 30 north, 80 east, and A is 80 north, 60 east. Then we are told to find the difference in longitude. So we can see that prime meridian is here, 0 degrees prime meridian, and A and B are on the same side. A is at 60 degrees east and B is at 80 degrees east, and therefore the longitude difference, because they are on the same side, we subtract. B is at 80 and A is at 60. They are both on the east side. Therefore, this will give us 20 degrees as the difference. As the difference, like that. So that's how it is done. I want us to mention something else. Distance along a great circle. Distance along a great circle. We know that great circles are longitudes. Therefore, we want to get the distance along a longitude. It is good to note that. It's good to note that distance is measured in a unit called the nautical mile. The nautical mile for sea, or in the sea, and in the space. Therefore, for us to get the distance which has been traveled by a ship or by an aeroplane, we use some units called nautical miles, though they have a relationship with the meter and the kilometer for that matter. So we say that for the difference in longitudes, we say that 1 degree is equal to 60 nautical miles. Nautical miles is abbreviated NM. Therefore, 1 degree is equal to 60 nautical miles. And therefore, to get the distance between two places, along a great circle, we multiply. We multiply the difference in latitudes by 60. Therefore, what we do here is, for us to get distance, we take beta and we multiply it by 60. This is distance in nautical miles. So you find in this formula, beta is the difference in latitudes. Because they are on the same longitude but different latitudes, for us to get the distance, we get the difference in latitudes, we multiply by 60, which is a constant. Let me give an example. If you're told to find the distance between P, and the coordinates of P are 40 degrees north, 50 degrees east, and Q, which is 20 degrees in the south and 50 degrees in the east. Find the distance between P, which is 40 degrees in the north and 50 degrees in the east, and Q, which is 20 degrees in the south and 50 degrees in the east. This is what we do. Solution. You first of all sketch these places. 0 and 0 equator. Therefore, 1 is at 40 north, degrees, and 50 in the east. 50 in the east. Therefore, where 40 north and the 50 east are intersecting, that's our P. Q is 20 south, so Q is on the other side. 20 south and 50 east, so they are on the same longitude. They are on the same longitude, 50 east. It is the one cutting across. So this is Q. We have said that for us to get distance, we take the difference in latitude, we multiply by 60. And P is in latitude 40, north part. Q is latitude 20, in the south part. Therefore, now, the latitude difference, because they are on opposite sides, it is 40 and that 20 on the other side. And therefore, it is 40 plus 20. Then we multiply by 60 now, which is a constant. This is 60 by 60, which gives us 3600 nautical miles. Nautical miles. So that's how it is done in nautical miles. I want to explain how distance can be gotten in kilometers for great circles. For great circles in kilometers, I will use this globe to illustrate whatever I want to mention now. It is good to notice this, that now, if we consider the Earth to be a perfect sphere, then for places along a longitude or a great circle for this matter, you find that we can use the center of the Earth as a reference. Then we say that now, because this is the globe I am talking about, if places are on the same longitude like this, then we consider here to be the center of the earth. So you find a place is here, our P, and another place Q is here. Then we consider this to be the center of the earth. Then you will find that we can have, because the places are on the surface of the earth, and this is the interior of the earth, then we can consider this to be the radius of the earth, like that. Then we consider now this one as the angle between the two places from P to Q. We have an angle in between, and we can extend a line for the two places to bring us to the center of this sphere. Therefore now, we can argue that now PQ is an arc. So when we are considering the earth to be a perfect sphere, though an assumption, then we argue that now from P to Q, it is an arc, and there is an angle between them. And because, can I assume this is the equator? Because the two places now are on the opposite sides of the equator, then we can say, if we say P is on latitude 40 and this one is latitude 20 on the south. Therefore, the angle in between, because we have 40 in the north and 20 in the south, then we can say the theta is 60 degrees, and the radius of the earth is always a constant and provided as 6370 in kilometers. Therefore now, because we have the radius of the earth and this angle in between the two places, then we can calculate arc PQ. And we know that the length of an arc length is given by the angle subtended at the center divided by 360 to pi r. In this case, r is the radius of the earth. Therefore, to get the distance in kilometers for these two places now, we will have theta as 60, because we have 40 in the north and 40 in the 20. That's a total of 60 divided by 360 times 2, a pi of 22/7 times 6370, which is the radius of the earth. So you find that for distance in kilometers, then we use the formula which is used to get the length of a normal arc. And this gives us by 6.1 by 6.6. So this is a 22 by 2 times 6370 divided by 7 and by 6. 7 times 6. And we get the answer as 6673.33 recurring. These are now in kilometers. Therefore, the distance can be calculated in kilometers by considering the distance between the two places to be an arc, assuming that the Earth's surface is a perfect sphere. So that's how we get the distance between two places along a great circle. In the next lesson, I'll be showing you the distance between two places which are on the same small circle or on the same latitude. Thank you for following us. Subscribe to our channel. Just below the headline, the word subscribe appears in bold red. Tap that button and you'll be subscribed to our channel. Thank you.